AI and quantum, hard truths. AI unfiltered what AI really is. AI is not magic. It is a stack of statistical models that ingest data, minimize loss functions, and output probabilistic guesses. No consciousness, no understanding, no common sense. Just pattern matching at scale. Learning means curve fitting. Training is brute force optimization. Adjust millions of weights until the difference between prediction and label is acceptably small. The model does not learn concepts. It memorizes correlations that happen to hold in the past. Data quality crisis. Datasets are riddled with mislabels, scraped junk, and societal bias. Models amplify whatever skew they are fed. Garbage in, gospel out is the default, not the exception. Models versus systems model not equal system. An AI model is a frozen artifact, matrices of numbers that map inputs to outputs. An AI system is the living deployment pipeline. Data ingestion, retraining, monitoring, compliance, and user interface, where most failures occur. Hidden technical debt systems rot faster than models improve. Legacy features, glue code, and undocumented thresholds accumulate until performance collapses. Teams spend 90% of effort firefighting integration bugs, not refining algorithms. Ownership gap. No single person understands the entire system. Data owners, model developers, DevOps, and legal each hold fragments. When the pipeline drifts or discriminates, accountability evaporates into ticketing systems and blameless postmortems. Quantum computing exposed superposition and entanglement. Last microseconds before decoherence destroys them. Keeping 1,000 logical qubits stable requires millions of physical qubits. Cryogenic dilution refrigerators and error rates still orders of magnitude too high. No practical speedup. Yet except for contrived benchmarks, quantum computers are slower and less accurate than classical ones for every real-world workload. Claims of supremacy rely on academic problems engineered to favor quantum hardware. Algorithmic mirage. Only a handful of algorithms offer exponential speedup. Most promised applications, optimization, ML, finance, gain at best quadratic or constant factors, and only if hardware reaches fault-tolerant scales that do not yet exist. Hype economics funding. Bubble venture and governments pour billions into startups whose roadmaps depend on physics breakthroughs that may be decades away. Valuations are driven by press releases, not revenue, creating incentive to overpromise and underdeliver. Talent misallocation. Thousands of PhDs optimize toy algorithms on NISQ devices instead of solving pressing classical problems. The same mathematical talent could improve power grids or climate models today, rather than chasing asymptotic speedups tomorrow. Security panic. Post-quantum cryptography is already deployable. The real threat is harvest, now decrypt later. Yet organizations delay adoption because vendors profit from selling fear instead of boring, effective migration plans. Integration realities. Hybrid quantum classical workflows sound pragmatic, but data movement between cryogenic and room temperature domains annihilates any theoretical gain. Most demos cheat by putting the heavy lifting back on classical GPUs. Cloud lock-in. Proprietary cloud APIs with opaque queuing, calibration drift, and pricing per shot mediate access to quantum hardware. Users trade scientific insight for marketing dashboards that hide the true error rates. AI on quantum? Running neural networks on quantum circuits multiplies resource requirements without clear benefit. Linear algebra primitives map poorly to gate sets. Training gradients vanish or explode once qubit count exceeds double digits.